Okay, so today we're going to continue talking about linear systems of equations, specifically how we solve linear systems of equations. The last method, and that was what your test was primarily over, for solving linear systems of equations was by graphing. Essentially what both of these equations in this system here, 3x plus y equals negative 3, and negative 2x plus y equals 7, they're both linear equations. So if you graph them, they both form lines on the grid. And if you graphed both of these lines, both of them would intersect at a certain point, and that point is the solution to the system of equations. So looking for the x comma y ordered pair where those two lines intersect, that is the solution because the x value can be plugged into both equations and it would output the same y value for both equations. That's the first method, basically just seeing where the two lines cross. The other method that I think is maybe less useful but is still an important method is understanding that in a table, so if, for example, I had a table and the first column was my x's, the second column was the y value for the first equation, the third column was the y value for the second equation, you should understand that if the two y values are the same for the same x value, this is my solution. The table method isn't really good for finding your solution to a system of equations, but you should at least be able to identify when they show you a table that this is my solution, 1 comma 3, x is 1, y is 3, because for the x value 1, y is 3 for both. So graphing and tables are the two methods we've already learned about how to solve linear systems. Any questions about that method? Okay. For the next test, we are still talking about how to solve linear systems. The only difference is this time, instead of using the graphing and table method, the focus is on substitution, which is the second method I'm going to teach you, and then the third method, elimination. So you should really have 3 or maybe 4, depending on how you categorize the different methods for solving linear systems. So I'd say graphing is the easiest method. If you can get both the equations in y equals form, just put them into Desmos or your graphing calculator, and look where the lines cross, and that's your solution. I'd say that's the easiest way. And honestly, when you're taking your STAR test or any official test, they're not going to force you to use one method or the other. Sometimes certain methods are easier than others, and most of the time graphing is going to be the easiest. But your upcoming test is going to test that you actually know how to use substitution and how you use elimination. So you're going to have to know these methods well enough to answer questions about what would be the first step of substitution, what would be the second step of substitution, and so on. And you're actually going to have to know how to substitute and eliminate when we get there. So I'm going to go ahead and first talk about what substitution is, and then we're going to walk through the steps together. So essentially the goal here is, if you look, both of these equations have two variables. So I can't currently solve them to see what x is equal to, what number x is equal to, or what number y is equal to. If we have an equation or a linear equation with two variables, two unknowns, we can't solve to see what one is equal to. So the goal of substitution is to isolate one of your variables in these expressions or these equations and then substitute one variable for the other. So if I can replace this y with some x's, or x plus something, or 3x minus whatever, then I'm going to have an equation that only has x's, and then I can solve to see what x is equal to. And that will make more sense in a second when I actually go through the process. But substitution is basically solving for one variable and substituting into the other equation. So let's go ahead and get started with our first step. So what you need to do is you have two equations here, 3x plus y equals negative 3, and negative 2 plus y equals 7. We need to isolate one of our variables in one of these equations. And you can do either equation, and you can do either variable, but you need to isolate one of the variables in one of the equations. I would say it's probably easier in these particular examples to isolate y. You don't always have to isolate y, but it's going to be easier to isolate y if you ask me. Does everybody see why it'd be easier to isolate y? Okay, I'm going to say it's easier for y, but both of these equations would be equally easy in my opinion. So I'm going to just look at the first equation, and we're going to isolate y for that one. So I'm going to rewrite it under step 1, 3x plus y equals negative 3. Raise your hand if you think you know the first step to isolating y.
Minus 3x.
Yeah, we're going to subtract 3x on both sides. So when you do that, you get y is equal to, I'll bring down negative 3, and then since there were no x's on this side, 0 minus 3x is just negative 3x. So I'm going to rewrite it in proper slope-intercept form, just the form we're familiar with. Y equals negative 3x minus 3. I just swapped those two terms, but as long as they keep their same value, they're both still negative, then it's still equal to the same thing. Any questions about what we did here? Okay, so that's step 1. Step 1 is pretty familiar. We've been converting things into y equals form or slope-intercept form for a while. This isn't really anything new. But what we're going to do with it is a little bit new. So now that we know that in this system of equations, so essentially we're looking at one big situation where we're assuming both of these equations are true at the same time. And as long as we don't do anything illegal in the rules of algebra, all of the equations that we get are also true. So now that I solved for y, in this big situation, this system of equations, I know that y is equal to negative 3x minus 3. So these two expressions, y and negative 3x minus 3, are exactly the same thing in this situation. They're equal to each other. So if I ever see a y in an equation, I can technically replace it with negative 3x minus 3 because they're equal to each other. And that's going to be useful because we can now go back into the other equation. And this is where we get into step 2. We are going to take this expression, and everywhere we see a y, we're going to replace that y with this expression. So let's go ahead in step 2. I'm going to write my original equation. Negative 2x plus y equals 7. You have to use this other equation. So if you did the first equation and you solved it for y, you need to substitute this new expression into the other equation. So my other equation is negative 2x plus y equals 7. In this system, I know now that y is equal to negative 3x minus 3. So I can replace this y term with negative 3x minus 3 because they are exactly equal to each other. So I know that y equals this. These two are equal to each other. So where I see this y here, I can replace it with negative 3x minus 3. So I'm going to rewrite this equation again. Negative 2x plus, so whenever you go to substitute, make sure you always do this. Keep the sign that was in front of y, or whatever you're substituting, and keep the coefficient. If there was a number in front of y, you would need to keep that in front of what you substitute in. And then we are just replacing the letter y with negative 3x minus 3. Whenever you substitute, the other thing you need to make sure you always do, use parentheses. Anytime you substitute something into anything, always use parentheses because sometimes you'll have to distribute. And if you don't distribute, you're going to get the wrong answer. So this is the only situation where you don't really have to distribute, because in front of this parentheses is just a plus sign, which is the same as a 1, a positive 1 basically. And if I distribute a positive 1, is it going to change anything? No. So this is the only situation where you don't have to technically distribute. So I'm going to distribute the positive sign, but it's not going to change anything. So I'm just going to rewrite it. Negative 2x minus 3x, because a positive times a negative is a negative, minus 3, because a positive times a negative is a negative. So I substituted, and this parenthesis step is vitally important. If this was a negative sign instead of a positive sign, I would need to distribute that negative, and it would flip all my signs. If this was a plus 2, I would need to distribute that 2, and then I would get negative 6 minus 6, or negative 6x minus 6. So make sure that you always use parentheses after you substitute. Everybody follow what we've done so far. Because we know in this situation, in this system of equations, y is equal to negative 3x minus 3, I can replace y with that expression. And why is this useful? Because now if you look at this, we've used both equations to set up one big equation. And in this equation, how many types of variables are there? 1. So can we solve this equation for a value? Can I see what x equals if I solve this equation? Yeah. So let's go ahead and solve. The first step, do you see any like terms in that equation? Negative 2x and negative 3x. Those are the two terms I see that are like terms. So I can combine them and I get negative 5x minus 3 equals 7. I'm going to take it back up to the top so I have more room to solve. And we're going to continue the solving process. Raise your hand if you see the next step.
You move negative 3 to the other side.
How do I do that?
You do plus 3 on both sides.
Plus 3 on both sides. Perfect. So I'm going to do plus 3 here, plus 3 here. Make sure you do the plus 3 under the negative 3 and the other plus 3 under the 7. And you get negative 5x minus 3. Oh, nope, not minus 3. Equals 10, because these canceled out. Now, what's the last step for solving, Alyssa?
Divide by negative 5. Divide by negative 5.
Thank you. Divide by negative 5. And this negative 5 cancels. I'm just left with the x. And 10 divided by negative 5, negative 2. So now I know that in this system of equations, these two equations are equal to each other when x is equal to negative 2. So if I plug in negative 2 into both of these equations, they're going to output the same number, same y value. So I've already found half of my answer. Negative 2 is the first half of my answer. I just need to find the y value. So because I used both equations, I used the first one because the y, or the negative 3x minus 3, came from the first equation. And I used the other equation, I substituted that y value into it. I used both equations and I solved for a single x value. Both of these equations are the same at that x value. If you use both equations, both of them are going to be true for that x value. And now if I take this x value and I plug it in to actually, to be honest, any of the equations, if I plug it into this first equation, if I plug it into this second equation, or if I plug it into the y equals equation I got, I'm going to see what the y value is for this x value for both equations. So I recommend after you solve for one variable, you plug the answer from step 2 or the solution from step 2 into this isolated equation. It's going to be the easiest way to see what the y value is. So I'm going to plug in negative 2 everywhere I see an x in this equation. So y equals negative 3x minus 3. If I plug in negative 2, if I substitute negative 2 into that equation, I'm going to see what y is equal to when x is equal to negative 2. So x is equal to negative 2. Everywhere I see an x, I'm going to replace it with a parentheses negative 2. So notice how I kept that negative 3. Anytime you substitute, your coefficient needs to stay there. Now, what's negative 3 times negative 2? Positive 6. And what's 6 minus 3? 3. So the y value for both equations when x is equal to negative 2 is 3. So both of these equations output the same y value when x is negative 2, and that y value is 3. And actually, if you look at this equation, over here on the left, I'm going to rewrite it. Negative 2x plus y equals 7. I'm going to rewrite this in y equals form. I'm going to add 2x on both sides. And I get y equals 2x plus 7. Everybody see how I got that equation? Okay, so that's my equation for the second one. If I plug in this negative 2, if we didn't make any mistakes, this will output 3 also, because both equations should output the same y value for this x value. So y equals 2x plus 7. If I plug in negative 2, again with parentheses, I should get 3 again. 2 times negative 2, negative 4. And negative 4 plus 7 also equals 3. So you can see same y for given x. So it's our solution. This is just another method for solving systems of equations. You substitute an expression so that way you get only one variable and you can actually solve for an answer, an x equals answer, and now you can use that x equals answer to find what y is equal to. It's just another method. Maybe on this test you will be required to know and use this method, but realistically in the future you're going to have other methods. You can use graphing, you can use the table. Whatever methods are easier for you, absolutely you can use those instead. This is just another or alternative method. And again, if I were to take these two equations I have, I'm going to pull up Desmos real quick, y equals 2x plus 7, and y equals negative 3x minus 3, you can indeed see we get the same exact answer. Negative 2 is my x, and the y value for both of them is 3 when x is equal to negative 2. Any questions about this method before we do a couple examples?
Examples?